Assalamualaikum warahmatullahi wabarakatuh. My name is Ihsan Yassif. I'll be your presenter for this paper entitled Classification of Coffee Roast Levels using Multi-Layer Perceptron on MNDT or Microwave Non-Destructive Testing as parameters. The co-authors are shown on the right side. We have a few representatives from the Microwave Research Institute, where I'm from, and the rest are from UITM and one from Iran. A bit on the introduction. Coffee is a popularly consumed beverage. It is prepared by brewing roasted coffee beans or seeds from the berries of uh, some flowering plants from the genus Coffea. It is dark in color, bitter and slightly acidic. It contains caffeine, which acts as a stimulant for adults to perk up their day. And usually it is consumed in the morning to perk up the energy levels for throughout the day. It's enjoyed by millions of people worldwide. Um, Basically, how the coffee is prepared is that it's roasted till it is slightly black in color, and then steeped in grounded and steeped in hot water, and finally it is filtered in the beverage. Usually there are three types of roasts, which are light roast, medium roast, and also dark roast. So depending on the level of roast, you have different types of flavors. Uh, that some people they prefer light roast, or some people prefer dark roast, which is a bit bitter. So it's the spectrum of flavors depends on the roast, the roasting treatment that the coffee beans are given. This paper presents an intelligent method to determine the different levels of roasting based on data collected from the microwave non-destructive test method. So basically what MNDT or microwave non-destructive testing method does is that it reads certain microwaves through the item that you want to test, and based on these after the beaming process is done, some parameters called S parameters are collected from them. And in our work, the S parameters were fed into a multi-layer perceptron neural network, and we used it to determine the degree of coffee roasts. This is a bit more on microwave non-destructive testing. Uh, as I mentioned before, it employs microwaves to find certain characteristics of the item that we want to check. It could be used to find faults, cracks, or defects in structures. It can also be used to determine moisture content and other types of flaws present in the item that you want to test. Uh, some of the parameters that are being assessed by MNDT approaches include reflection coefficient, transmission coefficient, dielectric constant, loss factor, and complex permeability in relation to sometimes temperature, sometimes frequency. And these measured values can be used to characterize the materials being tested. Set up something like this. We have a facility in Microwave Research Institute. have MNDT set up here, where we have two antennas, I guess, that the one antenna eats microwave from it, and the other antenna collects data from collects the beam data. And what we want to do here is we put some materials that we want to test in between. So as the microwave is beamed through the material of interest, we get certain readings that we can use to characterize the material that we want to test. So the materials can be anything. In our setup is coffee, and there's a special container for it using perspex. So basically what we do is we fill in the coffee beans into the perspex container and beam microwaves through it. The different types of coffee roasts that we tested was the Verona, Cafe Verona. This is a dark roast from Starbucks. We have also Colombia medium roast from Starbucks as well. And finally, we have a light roast from Ethiopia. And this is, we got this from Coffee Bean. So we have three different types of levels of roast and three different types of coffee. The setup for the MLP is such where we have 5 hidden units in the hidden layer. For the input layer, we fed the S parameters from the microwave tests directly to the input layer, which the input layer is huge. It consists of 6,400 data points. For the hidden layer, we set the number of hidden units 5, and it was found to be more than sufficient for our experiment. So we didn't modify the what we call the number of hidden units after. And finally, in the output layer, we have the different types of classification, namely light roast, medium roast, and dark roast. Bias connections were added to the input and hidden layers to accelerate convergence. Bias units are typically known to help improve the convergence speeds. It acts like the normal input unit or hidden unit. However, the value for the bias is always 1. So based on these experiments, we perform the training process. The neural network learned well. As you can see here, using the cross entropy performance function, you can see that the performance is approximately 4.42 times 10 to the power of 7, -7. So it's quite good. And once we've done that, we tested the results using the confusion matrix to determine whether the results were good. And surprisingly, we found that the training, validation, and test confidence matrices were all 100% accuracy. So this means that using a relatively small neural network and with even with a very big input size, we managed to obtain something quite remarkable, I guess, in terms of the accuracy. And we are planning to expand this research. For your information, this research is very early stage. However, we are planning to expand this research to include um, not just the classification of the types of rows, but the effect of oxidation um, into the values of S parameters. So that will be our future work. So in conclusion, in this paper, we have shown the capability of the MLP categorize between different types of rows for coffee. It could differentiate between the rows, different rows, with a modest, very modest actually, it's a very small network. However, the results are very good. With the results shown here, this work can be further extended as different levels of coffee oxidation, as I mentioned before, using MNDT techniques. So with that, I end my presentation. Thank you very much. If you have any questions, please ask during the Q&A session. Thank you.